going to be an infection process, and then the product of infection process is going to be a disease. So those are things which we need to mention. It's not very hard, really. It's a very beautiful part which we are going to touch. And then you understand this one. It is good for you to touch innate immune system in 21, acquired immune system in 22, hypersensitivity 23, and then we are taking, instead of chapter 24, we are going to take chapter 10, which is going to be drugs. We may focus. It's a very good one, really. It's not hard. It's very beautiful. So what you need to do is, look now, infection causing structures like bacteria, you know it. We don't need to mention it again and then again. Look now, you are having bacterial structure, which we call them antigens. And then among the antigens, there are virulence factors. Those are enzymes. They are pathogenic character calling type of antigens. So those virulence factors are antigens. Antigens are subunit of that microorganism. And then with that antigen, disease-causing character is going to be a virulence factor. Those virulence factors are mostly, they are enzymes. Those ones we will touch today, really. It's very interesting. When we are going to touch about bacteria, look now, in bacteria, okay, when we are going to talk about bacterial structures, we are going to say bacteria which are mainly divided into two. The third one is Mycobacterium, which act as gram-positive bacteria too. So according to the cell wall structure, bacteria can be gram-positive and negative bacteria. Okay, now those gram-positive bacteria, they are producing exotoxins, and gram-negative bacteria are producing endotoxin. Endotoxin is membrane protein, which is related to, which is very attached to lipopolysaccharide in gram-negative bacteria. So gram-positive bacteria, they don't produce endotoxins. And those bacteria which are producing endotoxin are more dangerous than gram-positive bacteria. Why? Gram-positive bacteria, mostly they are on the surface of our body, and then gram-negative are mostly inside our body system, and then they are using their antigenic structure as a virulence factor or disease-causing factor. You see, so for this reason, you need to remember it when we are saying flagella. Flagella are antigen. Is there a certain virulence factor there? Yes. Okay. Somehow, you see, if there is no virulence factor, antigenic structure, they cannot protect you through vaccination. You see, so we are going to form antigen, and then that antigen infused in the form of a vaccine, introduced to your body, and then forming antibody. There is certain strong triggering antibody triggering structure exists. Those factors, one of them is a virulence factor, you see now. So it is not only causing a disease, it is also, it is having certain antigenic structure. Okay, now for growth factor, okay, for protection system, those structures are very important. For example, fimbre, you see, fimbre is adhering character in bacteria. Bacteria says, I love you, I don't want to leave you, and then attach to your host system. Our host system, those are fimbre, you see, those are antigenic structure of the bacteria. Yes, no. And then when we are coming to understand the pili, genetic information of the bacteria, does it have antibody? Yes. If you are going to introduce it in the form of vaccine, you are going to find antibodies also. So antibody, when we say for certain microorganism, is collection of antigenic structure reflecting in your body system. Really. Hazel, it is a repeated action here. Just I'm using earphone, and then any sound coming is disturbing you a lot, really. Please. Okay, now. Well, here antigenic structure I mentioned. I don't want to repeat again and then again on that. So viral origin. We know in virus, the central core is containing virulence factor, except RNA and then DNA virus, there are certain proteinic structures exist. All viruses, they don't have that kind of enzyme. Why? They don't cause a disease, some of them. They don't inhabit in our body system without harming us. Okay, now, so there are certain viruses, maybe they don't show any pathologic effect, no clinical symptoms. That means they are not going to alter our body system, you see. But the ones which are having enzymatic character, the virulence factor, they are going to make it, you see, they are going to make a certain kind of disease, you see, pathologic effect they show in your body system. It can be an organ, it can be a cell, it can be tissue or organ, or it can be on a system, you see. Reflection what we have seen as a product of infectious process, this is a disease, you see. So viruses, they are having in central core the virulence factor. That's very good one, you see. Now when we come fungal origin, when we say fungal origin, we are saying yeast, or we are saying also mold, you see, mold. Mold, they are hyphenated, they are multi-hyphenated type of structures, you see. So except the hyphae, there is sporangium. Before the sporangium, they are having mycelium, which is anchoring this hyphae onto the ground, you see. So mycelium is having a toxic effect also. Hyphae, it does. Sporangium is the worst from viruses, from fungal origin, which can cause a disease. Sporangium, it can produce a spore. Those spores are coming little stronger, and then inhalation, or somehow they are infecting certain product, or you can find them in certain product, and then you can be infected, you see. So from fungal origin, we have it. A disease also, we can be infected, you see. So that is very interesting. I'm not going to mention deep on that area. Parasitic structures, we know we have some in blood, and then some of them carried by mosquitoes as a fly, and then some of them with roundworms. For example, this is tapeworm egg with tapeworms, and then we have ascaris also. Those are parasitic. For example, if you are going to take tick, it is going to carry gram-negative bacteria Bordetella bordiferi. Is it gram-negative bacteria? Look now. So the parasites are carrying arthropods in their body system. On the segment of on legs, they are carrying certain microorganisms. Mechanically, they can pass it also. Mechanically, they can pass it. You see, if we are going to say tick, yes, suck it up from infected animal and then pass it to us. Yes, biological carrier they are. But if they are going to carry in their body, there's a mechanical way of transmitting a disease, you see. So it's very interesting. If we are taking roundworms, the ascaris, you are going to take the egg with contaminated cabbage, contaminated water, you drink it, and then the eggs are changing to larva, the larva to the adult ascaris also. So parasitic origin is known also. Okay, viral origin, we mentioned, you see pox virus, influenza type, COVID case, and then now rabies case. This kind are having certain virulence factor. You see, without virulence factor, they cannot cause a disease. So look now, bacterial diseases, for example, ear infection, streptococcus, and then epidermidis type, anthrax on the skin, and then you are going to find certain viral origin also. Pox can make like this vesicles when they dry up like that, it can make. Mostly viruses are depending. Oof. Hey, this Campbell, this is 2 or 3 times you are using. Please, can you stop? And now when we are going to come on other case, you see this mostly viruses are depending on your epithelial tissue, mostly. And there are certain bacteria also. For Staphylococcus epidermidis is going to make a wound on your skin too, you see. So that is what you can understand from bacterial origin. For example, there are certain people are using dogs, and then dogs are really faithful and then kind. You train them, they are good family members. But sometimes when they are leaking, there are certain microorganisms they carry. They are not going to be sick, but they are going to pass to you that kind of disease. For example, cats, especially, they are going to kiss you whatsoever. They can come closer to you, but they have a scratch. Bacillus gram-negative bacillus group, scratch disease we call it. So they will not be sick, but they can pass that kind of disease. It is itchy type, itchy. You see, so those kind of diseases, they pass. So for this reason, you need to be careful when you are going to have relationship with animals also. That I don't go deep because we like animals. Now, here now, microorganisms. When we say, when they are entering, you see, now our topic was disease and infection. Now, infecting agent enter to your body in different ways. That we call it port of entry. Aha, port of entry. How they enter. If you come from Mexico, port of entry in between America and Mexico, there is. But when I come from Ethiopia, I fly directly to Los Angeles. Los Angeles is my port of entry to USA. Look now. So for this reason, port of entry, when we say microorganism, how they enter to your body, they can enter in your eyes, nose, ears, lacerated skin, with private organs, and so on. In through anus, from mammary glands area, they can enter. That means through the skin they can enter microorganism. That all we call port of exit. What about port of exit? Okay, port of exit means the same bacteria enter to your body is going to release. You see, from through your mouth, through your ears, whatsoever. So we call two of them: port of entry, opposite port of exit. How enter the body, cause a disease, and then bypass or by certain clinical symptoms, they are going to release from our body. You see, that is, you need to understand the two words, please. Port of entry and port of exit. Microorganisms are going to be released. Step one, for example, Ascaris enter, and then the Ascaris is going to lay eggs, and then those eggs are coming with a stool, and they mix it up with the soil. Again, they are going to infect, and then they are contaminating the what? The water. They are going to come back again. So that is how we say port of entry and then port of exit. Two of them you need to know. Maybe on your exam there is, maybe on final exam. Those kind of words, I like them. I choose from your questions, those ones. Now, pathogens. We are saying parasitism. Any microorganism, depending on you, because they don't survive by themselves, we call parasite. But the word is not right exactly. I didn't write this book. So parasitism is on a parasite. You see, in a parasitism. There are helminths, roundworms, whatsoever, and then the lice, the pigs. We are saying parasites. But bacteria and virus, usually we don't say parasite. They are infecting agents. And then the process called infection, see. So I didn't write this book, but I will accept it as parasitism. Parasite, because they cannot live by themselves, they are depending on another, we call them parasite. Okay, now. So, pathogenicity. Pathogenicity is when microorganism enter into your body and then altering your normal host condition. That we call it pathogenicity. We mentioned this word so many times, more than 8 times really. Patho means destruction, genicity means development. So destructed structure is going to alter, you see. It can go maybe tumor cell, or it can be lesion, it can be pus forming. That all is pathogenicity, you see. And then for pathogenicity, or to cause microorganism pathogenic character or to alter, they need virulence factor. Virulence factor. We will mention that one, is very good word. Today we are going to talk on those ones. Okay, now, so when these microorganisms are attacking us, we call exogenous infection also. The ones which are coming, pathogens are breaching the host system from external part of your body. So we call exogenous, from outside, exogenous. If we are saying endogenous, from the inside. For example, there are Escherichia coli exists around rectum, our rectum, to digest some foods which are not digested will be broken down by Escherichia coli. Okay, one. And around vaginal area, we have lactobacillus bacteria. That lactobacillus bacteria, during menstruation, it can pass the cervix, and then it can infect the uterine area, and then that is going to be endogenic. There are microorganisms already inside, but when you are doing surgery, maybe, and then when you are going to have intercourse, and then during menstruation, from that area, the microorganism from vaginal area go to the cervix and then pass to the uterus, and then they are making foul smell. And then the people who are infected, we may show that kind of smell. So these all endogenous. So that's why we our sisters, especially when you are during those 28 days appearing character, you don't need to meet with someone at least minimum 5 days after the menstruation has gone. Never. You see, otherwise the cervix is open and then anything can enter back by penis or by any way when you are going to take shower even. No shower, baths you are taking. Through baths, it can penetrate also passing cervix and then to the uterus also. So for this reason, when you are having in those cycles, you need to avoid taking baths. Instead, you need to use a shower. You see, those kind of ways, endogenic microorganisms, how they are going to penetrate inside our body system. That's good. Even if you are having, our mouth is, for example, more contaminated. Around 8 billion bacteria exist in your mouth. So the gum is bleeding, and then you have certain bacteria. Because of those bleeding, they can go into the blood capillaries, and then they can infect you. But these are in oral cavity, you see, in oral cavity. So they breach that system and then cause a disease. So they are there already. You see, so those kind of things which you need to understand, they are penetrating to a sterile condition and then altering and then calling pathogenicity. We call it endogenous infection. So opportunistic microorganisms, these are microorganisms that are not virulent enough. Really, they are not virulent enough. Why virulent enough? Their antigenic structure, they cannot alter so many characters on a cell or tissue or organ or systems. So what they wait is, when your mechanism defense is lower, they can attack you. They can attack you. Why? Aha, because you give them. During menstruation period, if there are certain bacteria like even this lactobacillus, when it penetrates, it is going to fresh area and they multiply there. Okay, one. Around your mouth also, this microorganism during maybe teeth extraction, there is cavity, and then in that cavity those microorganisms enter and then they are going to infect you. So those are opportunistic microorganisms. Opportunistic microorganisms are going to be very dangerous during the surgery period. For example, on your skin, bacteria which are going to live symbiotic life. So they are opportunists. They want to suck some kind of sweat from you and then they survive. By that help, look now, they survive in you or on the surface of your skin. So if there is a laceration, then they enter. Those are opportunistic microorganisms, you see. They are on the surface of your skin, but when they are getting some kind of laceration or doing surgery, during the surgery period, they can penetrate and then they can cause a disease. So they are waiting comfortable condition to cause a disease. You see, those we call it opportunistic. Those are theories now. Okay, now, when we are talking about disease and infection, we need to know mode of transmission. How is it? Is it direct contact, by sexual transmission, or by droplet? Those are ways how microorganisms are penetrating to or infecting you. You see, so there are means of transmission by insect or fomite from non-living things. For example, microscope. If you are taking microscope, somebody use it, not cleaning it, and then you work with your hand with microscope and then touch your eye or your mouth, there are microorganisms, and then the mode of transmission is mechanical. You see, mechanical. So mode of transmission, it can be biological and mechanical. For example, the flies carry some kind of germ on their legs, whatsoever, carry that germ and then pass it and then put it in your food, and then you are going to get it. That is mechanical. But if they are going to suck up from sick animal and then passing to you by punching your skin system or whatsoever, that is biological. You see, biological, by living things. So those are mode of transmission, mechanical and biological, or we call by format and biological ways. Port of entry we discuss, post of exit we discuss, reservoir. Every object or every person who is holding microorganism or being sick in the past and then holding microorganism in their body system, we call reservoir. Even though they don't show clinical symptoms. For example, if you are going to sick infected with tuberculosis, TB, within 6 months, it may show you clinical symptom. But sometimes people being sick, and then that it, when you are going to take medication, they are going to make a what we call it, carbuncle. In that carbuncle, they are going to make it inside, and then they are not going to release outside. So they are assisted in that host system. So for this reason, they will wait, and then when your mechanism defense is lower, they will start. You see, surgery or certain problem you have it, or when you are coming at age of 80, your body is going to decrease 50 system and 50%, or when you are having this natural killer cells, cell mediated immune system, humoral immune system, which are going to be reserved and then produced by T thymus. And if they are going to be atrophied at the age of 25 and 30, your mechanism is coming lower because the lymph node and spleen are taking over. You see, those are not real manufacturers of protection cells in our body system. You see, those are how they are exposing us to be susceptible for certain kind of disease. So mechanism defense is very important, really. And if you are going to take alcohol, you are too much smoking, and your mechanism defense is lower, yes, you can be exposed for certain kind of infection from different etiology, different ways. So if it is strong virulence factor or low strong virus or virulence factor or low dose of microorganism or medium level of microorganism, depend your health system. For this, diet and then genetic information is very important for that. So we are not going far in that area. Transmission, look now, for how many of us we do like this, share, you see, we do it, okay? Animals share. Animals live together. If one is sick, then we are going to pass it. So they don't keep a distance. PPEs, they don't keep, you see. So we are the one to take care of it. And people who are going to be infected with certain microorganism, some of them with tuberculosis case, 3 meters, they can infect you by droplets. 3 meters. Look now, how it is very dangerous. We are going to transmit diseases. So it can be direct contact or by droplets you can pass a disease. Okay, now here transmission also in indirect way. Look now, microscope. Somebody contaminated and you can be infected. Wow. And then look now, here there are certain vessels which you can use in the kitchen area, certain biological factors, and then ticks, and then contaminated water, or these all are going to contribute the transmission of the disease. That is generally good one, really. Okay, now, so we are coming to understand primary infection, secondary infection, and systemic diseases. So you know these ones. Just I will give you a clue on that one. What do we mean when we say primary infection? Primary infection means if you are going in pathologic process, pathogenesis going on in host system, in your body system, then the first microorganism which infect you is going to be primary infecting agent. So we call it primary infection. Okay, now, for example, if you are going to be infected with TB and then HIV, then if your mechanism defense is lower because of body diet and then body genetic information, and then that is going to primary infection, TB. And then TB lower your mechanism defense, and then HIV take over. So in your body system, there are 2 diseases now, Mycobacterium and then HIV. HIV or AIDS. So what you need to do is, firstly, you are going to prepare your box. TB is there and then HIV there. So one is making your mechanism defense lower, the other is governing. So for this reason, primary can be tuberculosis, secondary can be HIV, or primary HIV, secondary can be tuberculosis, depending how in what condition you are being infected, you see. So that is depending the age also. If it's young, old, or middle age, it makes it different. HIV first or TB second. TB first and second. So those are different ways which we do. But when we say secondary means the first attack you, mechanism defense is lower, the second will attack you. When we are saying systemic diseases, these are diseases which are going to disseminate in all parts of your body, all the systems. We have about 12 systems in our body. Certain people will say 11. I agree with that one. When reproductive system is collectively, this is 11. If a male and female reproductive system, we are having 12 system in our body system. So we are having 12 system in our body. And then when we say systemic disease, means that microorganism, it can pass by blood circulation all part of your body. That's why most of the time when you are infected, temperature increases, inflammation goes on, the blood will be taken and then analyzed to culture or do serological reactions. So about the serology, we will come on chapter 23 area. So that's very interesting, really, very interesting. Nothing is hard on this one. You know it. The ones who have studied biology, even high school, 10th, 11th grade, that is what I discuss now. It's not new. So here what we are saying, pathogen enter to your body, and then to enter, it needs some kind of adhesion character. For example, we say bacteria has fimbre. Fimbre is adhesive character for that microorganism. It will attach and then say, no, I don't want to leave you. I love you. I like you. I want your cell. I want your tissue, it says. So that is adhering character. Even if it is on the table, it can stay. If it is on the on your body system, it can stay in your body. Even if it enters to your GIT system or cardiovascular system, it stick to the wall of those organs and then will not disseminate or stays there until it develops its own genetic makeup. Then it is going to be using a character of adhesion. You see, adhesive character. So fimbre is adhesive character for bacteria. So when we are saying infectious dose, most of the time you know it. We studied that one in 10th grade and 11th. Lethal dose, we call it, really, in biology. Lethal dose. Lethal dose means the killing dose of microorganism. Mostly they say lethal dose of 50. 50 microorganisms are normally to kill someone. You see, but it is not depending only the number. For example, anthrax, 3-4 bacteria can attack you if you are maybe young, middle age, or old. Makes it some kind of distances, the variable distances, or clinical manifestation will be different. You see, but most dangerous bacteria like anthrax, which is containing PX01, PX02 on the cell wall, they are very dangerous on controlling the platelet formation of fibrinogen. You see now. There are certain bacteria, for example, destroy the red blood cells, okay? Leukocidin, we call it. And then there are certain bacteria only attack the white blood cells first, and then go to another histological cells or tissue cells, you see. So for this reason, infectious dose, when we say the number of bacteria which are introduced to your body to cause clinical symptoms or pathogenicity, you see, very interesting. That's very interesting. We are going to touch that one when we come to the drugs. It's very beautiful, really. So when we say the infectious dose is the number of microbes entering to the body. So that you need to know generally. You know it in the future also. So invasiveness is depending the virulence factor of the bacteria, the strength of the bacteria, you see. So the virulence factor means a disease-causing factor, antigenic character of that microorganism is the invasiveness, phenotypic or genotypic character, you see, invasiveness. It invades your body system. That means it kills your cell and host cells also. That means it is using its own virulence factor. It can be a gun, it can be any bomb, it can be something strong the bacteria may use, you see, that it may destroy your host system. Very interesting. Really, I like it how this is presented on this topic, really. So invasiveness, ability of pathogen to penetrate tissue and spread in the body system. So invasiveness. So many pathogens are use phagocytosis. Phagocytosis, when we say phagocytosis, those macrophage are coming together. Yes, this one we are going to touch in detail on innate and then acquired immune system. But I will touch you some. And here, phagocytes, when we say, these are white blood cells, especially white blood cells are consuming or eating certain bacteria. Okay, now, here, phagocytosis process is when microorganisms are going to grasp, you see, grasp our host system, and then they are using their own virulence factor, then our phagocytes are going to consume those microorganisms. Look now, it's very interesting. Those microorganisms, they are having a very strong virulence factor. So when our white blood cells hold them, and then when they are using like macrophage, and then helper cells, cytotoxic cells, suppressor cells in our body, they are, we call them like macrophage state, and then those are defending our body system, and then those ones, when they are running at the site of microorganism enter, and then grasp that microorganism, and then they want to consume them, that the bacteria, because it has virulence factor, it is stronger than our white blood cells, and then they are going to consume our cells. You see, that is how the pus is going to be formed. Pus, dead cells, dead our host cells, dead bacterial cells, but the leftover bacteria is going to multiply and then make its own offspring. So that's why there is mediation system exists. Macrophage is going to have helper cells helper, and then that helper cell, it cannot do it, and then cytotoxic cells, they have their own enzymatic action, cytotoxic character, and then they are going to kill the bacteria, and then the bacteria govern that cell, and then it can kill it. After that, we are going to see pathologic process, and then we are going to see clinical symptoms. Very interesting. Look now. So that is very interesting when we are saying about microorganisms, really. Look now, virulence factors. These are enzymes. You see, these are enzymes. And then there are, look now, it's very interesting. They are antigenic structure of microorganisms. But when they are going to destroy our cells, they are using their own enzymes, like we are saying in viruses, in central core, RNA, DNA are having the enzymes. Those enzymes are virulence factor of those viruses. In bacteria, we are having different enzymes exist. Especially, I'm going to mention about 5 of them. You see, so virulence factor, antigenic structure, strong antigenic structure, which are going to cause a change in a host system. So we call those are enzymes. You know, enzymes, for example, in our body system, we are going to understand them in the process of catabolytic and then anabolytic process. They are making the big molecules into small molecules. You see, that means big molecules we are broken down in our body system, and then for building structure for anabolytic process, they need to be minced, and then they need to be small sized, a small molecules they need to be. You see, so this digestion process is going to be carried by the enzymes. You see, enzymes. You know, we have enzymes. Salivary glands are enzymes also, which we are having around oral cavity. So what kind of enzymes we are going to mention? There are about 5 enzymes now. Look, very interesting, these enzymes. When I am giving face-to-face exams, I'm going to give for the students fill in the blanks on this exam, really. Now, here, when you are going to understand about the enzymes, look now, staphylococcus, in 2 ways we can call it. Staphylokinase, we call it. Is the enzyme character. Anytime, NCLEX exam you take, whatsoever, if it comes as ASE, it is an enzyme. Remember, it's very important for you. Now here, staphylococcus, when it causes some kind of a pathologic process in our body, it is using enzyme, we call it staphylokinase. If not, we are going to call it coagulase. You look now, it is coagulase and then staphylokinase, they are the same enzymes. They are produced by Staphylococcus aureus, especially. You know it. Food poisoning after 4 hours, you prepare and then or leave it on the table in the kitchen area, and then that is going to going to produce exotoxin. It's a gram-positive bacteria. Exotoxin is a virulence factor which is going to alter and then make him bubbling in your stomach and then vomit, nausea, whatsoever it can cause. So that is an enzyme. It is antigenic character of staphylococcus. Very interesting. Now, when we come to streptococcus pneumonia, we call it, and then look now, I'm sorry. Here, when we are saying now, look now, we are having staphylokinase, an enzyme from Staphylococcus epidermidis, which is going to form skin wounds, staphylococcus, or ear infection, staphylococcus. So there is an enzyme which we call it staphylococcus, and then streptococcus, and then the microorganism is streptococcus. You see, so that is very important, which we need to understand when we are talking about viruses. I didn't lock out my cell phone. Now, sorry, hyaluronidase. It is enhancing pathogen penetration through the tissues, through the tissue. Look now. So it's through the tissue it enters. That we call hyaluronidase. Certain bacteria are having hyaluronidase. That is an enzyme. And then there are certain leukocidin. Leuko means white blood cells, you know them. Those are neutrophils and macrophages. You see, leukocidin. Cidin means kill. Leuko means white blood cells. So this microorganism is having certain enzyme which is going to kill neutrophils and then macrophages. So we call it leukocidin. These are enzymes produced by the bacteria. Hemolysin, hemo means blood, lysin means breakdown. So hemolysin break down the red blood cells. Okay, very interesting. So those are enzymes generally you need to remember in your studies. So these are very interesting enzymes on bacterial production. Now look, when we are going to talk about infectious disease epidemiology, what does it mean, epidemiology? Epidemiology is the distribution of disease. It can be outbreak, it can be endemic, it can be pandemic. Okay, now, in the process of epidemiology, we are having three categories which we need to understand in the process terminology to understand what epidemiology is, where there must be a source, and then making the second one intermediate host, and then the third one will be the final host, the final. So there is a chain between starter of the disease source and then the final being infected. So we call that is epidemiology. And this is a subject which is a lovable subject, really, epidemiology. When you are studying, it's a very beautiful subject. So epidemiology is the distribution of the disease. So when the disease distribute, there are reservoirs exist, and then there are carriers exist. Reservoir means any places in the environment where pathogens can be found is reservoir. You see, a soil can be a reservoir, water can be a reservoir. Dead animals which are buried in the ground, and then they are forming spore, like anthrax case, they are reservoir. You see, look now. So carriers, when we say, these are recognized, the ones which are going to carry the disease, or the agent shed the infecting agent, like we are. For example, if I am infected with a tuberculosis at the early stage and then take antibiotic and then healed, there is tubercle which is prepared and then stay in my lung. You see, one day mechanism defense is lowered, it is going to burst and then show clinical symptoms. So for this reason, I'm a reservoir for that microorganism. Reservoir. So those are things which you need to understand simply by some ways. Okay, now diseases are also described by how they occur within a population. We call it endemic disease. These are habitually present at low level in a certain geographic area. Endemic disease. Endemic disease. For example, Ebola virus, which we have studied, it is going to be in Congo. That is endemic in Congo. You see, was it in America? Yes, because it is carried with certain people who were taking care of people in Congo area, and then they carry, even some doctors, nurses die in America because they were serving there, and then come back to America, they become sick. You see, so that is, look at, from endemic area, it can move to another country, and then it is going to be pandemic. You see, pandemic worldwide. But this disease, mostly it is endemic, like Ebola. There was some kind of clinical or dead people in Washington, New York area and Washington DC around, and then here also Orange County. You see, dead people with Ebola. But Ebola was endemic around Congo, around the Congo River area. You see, so around Ebola River area. So for this reason, it is endemic there. And then in Sudan, for example, there is flesh-eating bacteria, we call it. It is endemic there in Sudan, you see. You see, those are what we are saying endemic. If we are saying pandemic, COVID is pandemic, a good example. And then we are going to call certain diseases pandemic. Tuberculosis is pandemic. HIV is pandemic. You see, so we are going to see them. Even though in America we don't have so many patients with tuberculosis, there is some distribution exists. So you know these two of them. Outbreak, there is sometimes disease arrive. For example, H1 virus between Mexico and America. You see, I mean, Mexican and American territories, it came, and then by vaccination in some protection system, they stopped at the time of Obama presidency. Look now. So that is what we call outbreak. Never been appear, but it appeared one time. You see. So those ones we call outbreaks. Outbreak can be happen also. Nosocomial infection. These are diseases which are going to circulate around hospital setting area, hospital settings, around hospital, in clinics, animal, veterinary, dental area. You see, those we call nosocomial. Nosocomial. Why nosocomial? Look now here. Very interesting. I'm 64 now. Soon I'm going to be 65. Look, up to this time, I'm not going to use so many drugs, medications. I don't use them. Because my mechanism, my exercise, diet, which I do, I'm good with this. But when I'm coming 65, 67, 70, and then I'm going to take maybe about 5 to 6 medications. Why? Because my mechanism defense is coming lower. You see, defending system is going lower. I'm coming older, you see. And the other thing is also the people who were taking certain medication before, this is very interesting, hear me now. Certain medication, especially who are coming older, grandmas and then grandpas, when they are coming older, they were taking so many medication before. You see, they go hospital, treated in hospital, and then those people, they are making some kind of resistance for certain microorganisms. Yes, they can make resistance. Those resistance means those microorganisms, if they are rod shaped, they are going to change L shape, like a triangle. You see, a triangle, 3-shaped. It can be that rectangle divided into 2. Partially, it is killed with antibiotic, and then partially it is not. So the one partially left is resistant. Now look, because that resistant is forming L shape. So the many people who are going hospitalization process or repeatedly taking certain medication again and then again, they are having resistance on those microorganisms. You see, resistance. So certain broad spectrum antibiotic you use, you can kill them. Otherwise, they are going to carry it, but they reduce the amount of expelling, exiting bacteria, but still they can be in their body system. You see, so that is going to be nosocomial diseases. Mostly nosocomial diseases are going to affect people who are coming, new generation, young children, and then when people are taking care of them, you see, with a young age, never taken medication before, and then using those ones, they can be resistant also. It's very interesting. We will touch that one when we come to drugs also. So when we are saying nosocomial infections, means diseases which are going to transmit in a chain around hospital or clinical settings. So when we go hospital for flu, we are going to get gonorrhea. When we are going for gonorrhea, we are going to get flu. Okay, that is what we call it. It is routine reflection which we are getting when we repeatedly going to the hospitals. Now, if we don't have any choice, yeah, you need to do it. Okay, now, when we come, disease emergence. Okay, now, this we call disease and infection. We touch that all. And then how the disease is going to arrive. Okay, change in land use or agricultural practices. Yeah, so we are going to use, look now, Ebola is in forest area, rainy forest area. And then when you are going to live around, and then when you are working for the farm and then collecting coal or preparing something there, you can be infected. One. Secondly, we are using fertilizers from animal origin, from the bones of animal, and then leftover from animals are going to be practiced in agriculture also. What's going on? We don't know. Maybe they are going to breed in the environment. Look, cloning is going to be carried in the environment. It's not always we are going to clone in laboratory. Look now. For example, if you are going to take bacteria and viruses, when we say bacteriophage is a product of a bacteria and fungus. Two of them unite together in a swage system, they are making bacteriophage. Look now, it's very interesting. So for this reason, when we are saying about the disease can be spreading in agricultural practices, it is true. For example, chicken contaminated, and then they are by industry, packaging, whatever, going, and then it can infect industry workers. But they come from where? From agricultural area or from industrial area too. You see now. So for this reason, think about how we are going to change land use, and that land use, how it is going to affect us. The other one is changing human demographic. Yes, we are increasing. You see, most of people from agricultural area, they are moving to the cities. Demography is BCG, mostly it is not applied in this country. And then I am reflecting positivity for TB because I have antibodies, which are introduced and then gained through vaccination process. Look at here, this is one. And then there are certain people are coming from another area and then carrying it. For example, we say COVID come from China. Well, we don't know from where, but the literature says, and then written information says from China. Okay, let it be from Africa or China. It doesn't matter. Anyhow, it is out of America, this disease is coming now. So by whom? By people. Look now, that is demography. Movement of people from one country to another, and then it is bringing diseases also. Can you stay in one country only? No, you can't. Only America isolating itself from other country can live? I don't think so. You see, we need to penetrate each other. You see, we need to exchange. For example, American products, if you are going to see, most of them are coming from outside, really. Yeah. For example, I saw yesterday garlic. Garlic is imported from Turkey. In the past, I was thinking it is coming from China. Look at it. Is it coming from Turkey? Look, this is how we live, you see. Now, if you are going certain Asian store, Indian store, you go, Nigerian store, you go, and then you go Ethiopian store, you go Greek store, you go, you are going to get in those stores are Americans, not Greeks buying there. You see how we exchange together, you see. It's very interesting how we are. You see, we want to see how things from other countries in America. You see, that is demographic play a role. And then for population health. In America, we don't have this kind of problem. But yes, we have poor people exist. Yes, we know. All of us, we cannot be rich. This is one of the richest countries in the world. You see, America. Still, we are poor. You see. So poor people, we cannot avoid it. We can't avoid poor being poor. You see, we can't. It is biological fact. You see, every people, they don't work hard. Every people, they don't work equally. You see, so there are upper handing section in the community which are already opportunity. They are rich, their children are coming rich. If they are poor, their children are coming poor. And then a few of them are breaking the bridge and then coming to be rich. Otherwise, the richest children are rich always. Look, Donald Trump. His family are rich, and then he is rich. Look now. And then others are like that. There are certain people, they are not rich, you see. They are not. So if they are not rich, they are not getting enough education, they are not getting what they want, you see. So it is including health also. For example, there is a Jewish hospital exists in Los Angeles. That Jewish hospital is very expensive. Many people, they cannot afford to go to that hospital, you see, if it's environment. You see, that's very interesting. Now, pathogen evolution. Yes, these are developing now. We discussed this one in the past also. There are certain glaciers are melting. There certain viruses are developing from southern pole and northern pole. Now, certain viruses are coming now. Look now. So those viruses, we didn't see them before. But when it is melting, the ice is melting, the ones which are hidden are arriving in the environment. How many? Okay, one. Secondly, we are having laboratories which they are going to do disease investigation. In that area, there are so many microorganisms are circulating, you see, even though I'm going to consult you. Where there are hospitals, where there are laboratories, don't buy a house, you see. Not make residence, really. Hospital areas and laboratory areas. No, because those microorganisms can somehow emerge out from those laboratories and then hospital settings too, you see. So those are, for example, certain microorganisms, except releasing from laboratory, it is COVID case itself. From laboratory, it is kept, you see now. So it can be happening in America. Yes, it can be. You don't know it. You see, microorganism about 10 years ago are a few, maybe about 20,000 of bacteria. And now today we are having more, you see. After tomorrow, after certain years, we are having more. Why? Because they are going to spread in the environment. Don't think the microorganisms are going to reduce. No. COVID is going to join with another virus, is going to be worst virus in the future. We don't know. We are guessing, you see. So for this reason, think about the pathogen evolution now. So contamination of food sources. We know that water supplies, if the food is contaminated, water is supplied, contaminated, we can be infected. International travel, yes, we go certain countries, and then, for example, you go to my country, and then you can be infected with malaria. Malaria. Come to this country, there are mosquitoes exist. Mosquitoes are going to suck up from that person, and then people in America can be infected. Aha, look now. That is international travel. Failure of public health systems. Now, in America, I don't blame in America any society really. Anyhow, we are living good life in America really. We have one of the best systems in America in health system. Be proud, really. So it's good. A person cannot die simply on the street, you see, can go to the hospital and die, at least, you see. If there is somebody can take him to the hospital, you see. If a person is sick and then dropped it to the hospital is not going to take that person and then leave it on the street. It is illegal in America. In other countries, it's not, you see. You cannot go to the hospital itself in the beginning. You see, so American health condition is good comparing to other countries, really. Comparing to the countries which I have seen. Yes, yes. In Asia, African countries, European countries, maybe about 15, 20 countries I have seen, you see. So I compare with those ones, really. Even though I don't go in detail, but I have history of those, you see. So here now, public health is good in America. International trade is very important. That we discussed already, international trade also. And then we are bringing, you see, now in California, especially in Los Angeles, you are getting so many products from Guatemala, from El Salvador, avocado, which I like it. And then papaya from Mexico, mango from Mexico. Look now, these are very important ones. And then we are enjoying with those ones. Those are international trade, but it is good. Ionization exists in the port, and then they are ionizing the product that they cannot carry microorganism here. But is there escaping way? Exist? Maybe we don't know. Maybe. Okay, climate change. Yes, that is, I talked already, the South Pole and North Pole. And that is all when we are coming to our chapter 20, disease and infection, microbe relationship and epidemiology is on the same chapter 20. We discussed that one. It's good, really. And then it took us about almost 1 hour. Now, let's go on micro lab exam review. I'll give you some idea. And then remember it, I send you some information on announcement. Please go and then read that one about this exam, lab exam review. It is not going to be easy like the third exam. It's not. So you need to be very careful. It is a lab part. Read every information. There are 3 sections exist. 3 of them you need to focus. And then those are 3 of them, which are having about 22, which I am going to discuss now. And then there is gram staining 2-page paper. Why gram-positive bacteria is going to change to gram-negative bacteria. There is information, there's 7 of them. From those ones, for example, why gram-positive change to gram-negative? One is going to be when the bacteria is older, gram-positive bacteria is going to change to gram-negative. That is one. Secondly, if you are going to wash with alcohol longer time, and then you are going to wash it out, crystal violet, and then it is going to be gram-negative. Okay. Thirdly, if you are jumping a stage, of crystal violet and then come with iodine whatsoever, you are going to be also, that is going to be gram-negative bacteria. And then the other step also, if you are having too much washing also, it makes gram-positive bacteria to gram-negative. Those are 7 of them that is on the paper, read them. So I'm going to give you in multiple choice. So that is not very hard. That is one paper. Second, there is a quiz, 7 questions, 7 multiple choice questions. Student prepare for you. Those ones I posted for you also. That is, one is group 1, we call it those 22 of them. Group 2, gram staining. The third one is those questions prepared by students. They are good questions, really. 7 of them. I will pick from those ones and then put for you on the exam. So there are only 7 questions there. So 3 of them, you need to read it. And then from those 3 of them, the one which is having so many chapters, I will mention for you. Look now here. Please follow it. Let me take attendance. Attendance here. Okay, thank you. I took this one. Now look, these are 1 to 9. Okay, those all we will go in detail. And then the next one, look now. The next one is going to be 15 up to 15. And then the next one are coming from 16 to 22. All those ones I sent for you. But now, look, here. What you need to do, if you are going to read, you read it. But if you don't want, for example, effective hand washing, I am not going to ask you any question on that. And then bacteriological examination of water, I'm not going to ask you. And then these are 2 main ones I'm not going to ask you. Maybe food microbiology, I may ask you. I'm not sure. Sensitivity, antimicrobial sensitivity, I will ask you. But 21 and 22, I may not. This one already, you have it. I send you after your presentation last time. Okay, now, this one, you need to know. 3 of them, you need to know. This is 1 plus 1, you need to know. How you need to know this one? I'm giving you multiple choice. So liquid media, by consistency, all the media divide into 3 categories. So those are liquid media, solid media, and semi-solid media. Look now, I will ask you on the test. Remember, here now, the liquid media, tryptose bros. Bros is a liquid media. Solid media, tryptose agar. Agar is solid media. And then semi-solid is going to be SS media. For salmonella, we use it. You see, we are using this one also, semi-solid, for motility also. We use motility of the bacteria. Why? It is not solid. It is between solid and liquid. That's why we call semi-solid. Okay, now, remember 3 of them, you need to know them. Okay, now look, I'm going to give you, this is liquid, okay, semi-solid for motility, and then solid media. Here, I don't want any student miss this question. I'm going to ask you, colony forming unit are going to found only, you are going to find them only on solid media, not on liquid media, not on slant. I am going to give you on solid media. You can streak it or you can put it in it. I will mention for you. So remember, this is a joker word when you are going to read it. Okay, now look, from 3 of them, you see, liquid media, solid media. Solid media is very important because it forms colony forming unit. Remember that one. Okay, now, so the other part is going to be, look here, you are having, look, solid media, liquid media. Solid media, it is going to give you colony. That's why colony forming unit, we call it. This one is a slant. Yeah, it can show you, but not clear colony. But the best one is colony forming unit here on a plate. Okay, that you need to know it. And then the other one, when the bacteria grows, this is the best growth of the bacteria here. We call it logarithmic, or we can say it exponential. Only if you know this one is good for you. This one is adaptation period. We call it lag phase. It is not grown. Bacteria is not well grown. It is adapting. And then this is most bacteria are alive. And then this is the best wanted bacterial growth in research, vaccine production, whatsoever. So remember this one, growth of the bacteria. Okay, now on the second, importance of aseptic technique. This is the second, number 2. Look now, aseptic technique, you know it, this one. If I'm giving you multiple choice, you need to know it. Do not contaminate culture. Do not contaminate working area. Do not contaminate yourself. And then the fourth one, if you want, don't contaminate your neighbors. Okay, that's easy, you see, when we give you that. Remember that. How many times we have done on this one? It's very important for you to remember. That's all for aseptic techniques, which we need to know. So here now, pure culture technique. There are 2 of them here now. One is pour, P-O-U-R. You are pouring to the plate. Pouring to the plate. You see, in the beginning you put bacterial culture, and then the melted one, media, you pour it in. That we call it pour plate method. Okay. Now the other one, you see. The other one, look, pour method, you are pouring it, bacteria already there, but you are passing it, and then rotate it, and then leave it, you are going to find colony forming unit. Pour method, you will find it. And then the second one is strict method. Can you find colony forming unit? Yes. Look now, this is, sorry. I don't want to cough again. That's why I moved it. You see, here now. You are going to have liquid media, and then from liquid you can pass it to the plate. And here is streaking method, we call it. This is streaking. We will find colonies. So in pour P-O-U-R method, we have it, colony, and then streaking method, we have colonies. 2 of them you need to know. That's a good one. If you know that one, it's enough. And then smear preparation. Look now. On smear preparation, what do you do? Always you are going to make it a smear. Look now. You are making from solid or from liquid. The joker word is, look now, the joker word is, you need to air dry it. It can take 5 minutes. It can 10 minutes. It doesn't matter. But you need to dry it. Air dry, we call it. Don't forget, air dry. During staining, the last stage is air dry. Don't forget that. So that is how we do. It doesn't matter. Okay, now we are coming, you see, smear preparation, air dry. Don't forget it. It is on multiple choice already. Among those 7 ones, you have that one. Okay, now simple staining. Okay, now in simple staining, we are using methylene blue. What is important simple stain? We are using what? The shape of the bacteria only. The shape. Can you use here crystal violet? Yes. Can you use safranin? Yes. Can you use another one? What? Iodine even. You can use it. It can show you bacterial shape. That's all. We want bacterial shape in this one. The most important is bacterial shape. Okay, now that is how we do it. Capsule staining, we have 2 of them. Negative staining, what do you use? Negrosine or Indian ink. You need to remember that. Negrosine or Indian ink, the chemical, remember it. And then the second one is you are going to use crystal violet and Congo red, or you can use only Congo red. What they need to show, okay? Here it is now. You need to know the names. Look now, here it is negrosine, negrosine. And then you are going to see transparent capsule at black background. Black background. It is very interesting. So transparent capsule at black background. And then we use negrosine or Indian ink. Very good. That is how you need to understand. The second one, crystal violet and Congo red. What does it show? in this one. Look now, crystal violet and Congo red, purplish background, and you are seeing clear capsule. Here Congo red. Now, Congo red only, you are going to see yellowish background, transparent capsule. That's all which you need to remember. You don't need another one. That's all. It's good enough. I don't want to give you too much things to remember. Okay, now we are coming to this one. You need to know what are the ingredients, the chemical which we use in gram staining. You need to know 4 of them. 1, 1, half, and 1. Please don't forget. Even if I say alcohol or ethanol, it is the same. You see, if we can use 70% alcohol, can we use? Yes, but the exposure will be long time. That's all. So look now, is gram negative and gram positive. Remember, 1, 1, half, and 1. That is the joker word. You can find a question by this. Now, look, here is going to be gram positive and negative, gram negative, and gram negative. This is from Fresh Media. I think this looks like a drawing, animation. Okay, now, look, gram staining from the beginning to the last, it is purplish, bluish, and then finally, gram negative from the beginning, purplish, but finally it is pinkish because of safranin. Aha, because of safranin. Don't forget that one. Okay, cell wall, remember, peptidoglycan, gram positive more, less in gram negative. Lipopolysaccharide, outer membrane protein, in gram negative, not in gram positive bacteria. Remember those ones. And then gram positive bacteria produce exotoxin, gram negative bacteria produce endotoxin, because mostly they are infecting inside our body system or organs. Now, spore. Now, on the spore, you need to understand malachite, and then you need to have safranin. 2 chemicals, remember them, please. Now, in the spore, malachite, and then safranin. Don't forget them. And the concentration, whatsoever, what color they are, you need to remember. So if malachite in one paper it says green, in some it says blue. If you say blue or green, it doesn't matter. Okay, now, so here, look now, in this one, it looks like a bluish, you see, bluish here. So this one, I may have this kind of picture I may take, and then I may show you, and then is it gram, which chemical is it showing in this one? Is it showing what? In this one, safranin. In this one, it shows what? Malachite green. Those kind of understandings you need to remember. And then vegetative bacteria are red, spore are blue. You see, so those ones, remember them. Okay, now in this one, there are certain chemicals we use. Brilliant green we may use sometimes, so it can be green. Green will be spore. So here, as I said, you need to remember safranin and malachite. That's a good one for you. Here is very good one. Do a very good picture. So you need to remember those kind of pictures. You know, about 99% of the class, they know it. I have no doubt on that. So the 2 chemicals, you know it, malachite and safranin, we use heat system to warm up, because the spore must expand to take malachite. That's why we use it. Okay, now here it is vegetative stage and the spore. Okay, that we said already. Okay, now when we come acid fast staining, look, acid fast, we are using carbon fuchsin, acid alcohol. Please don't say acid or alcohol. Say it acid alcohol, and then methylene blue. Remember those 3 ingredients on acid fast stain. And then if it is acid fast, it is going to be red or pink. If it is non-acid fast, blue. So any bacteria you can mention like that, you need to be able to give me like that also. Look now here, carbon fuchsin, acid alcohol, and then methylene blue. And then if I have a picture like this or a picture like this, and then show you this one, and then this is what? Acid fast, and then this is non-acid fast. Remember this once. So by color, you can differentiate them. Okay, this is all we have done that. Motility. There are two ways. We have wet mount and then agar stabbing. So wet mount is on the slide. Agar is on the agar media. So how do you see this one? I'll show you this one. Look now. So in this one, by diffusion, this is triple phenol tetrazolium chloride. I'm not going to ask you those chemicals, but here it diffuses. This is positive, this is negative. And then here positive, this is negative. Okay, so that is how you are going to understand it. So remember, this one diffuses. And then this one, if I give you in the exam, this is positive, this is negative. You know it. About 100% you know it. So no problem with that. And then in this one, also positive, negative, positive, negative. That is a different way exists, you see, in the book. Effect of oxygen on growth. Here you are going to understand something. Look now, anaerobic jar, we use it. Anaerobic jar is important to grow bacteria, facultative, or bacteria which are using carbon dioxide only, anaerobic ones. This one you need to remember. Look, this one, you need to remember this one. I will give you this picture and then give you multiple choice like this. So remember these ones. So what are they? You see, these are obligate aerobic oxygen need, carbon dioxide need, small amount of oxygen, and then these are facultative ones. Now then, I will remove this one and then I will give you a choice. So remember these ones. And then this is the gross, how we are going to differentiate. Remember this part on the gross, logarithmic, log. And then when we are coming to the temperature, I'm not going to ask you on a temperature. You know why? Because temperature scale on your textbook and the lab book are different. In your lab book, it is going to be -5 to 20 is psychrophil refrigeration system, and then from 20 to 50 mesophils, thermophils 50 to 80, and then hyperthermophils greater than 80 or equal 80. So for this reason, I'm not going to ask you this question on this one because two of them are conflicting one another. Okay, now here pH and then microbial growth. You need to know this one. Maybe I may ask you, maybe. Look now what you need to know. Here, I'm not going to ask you a scale like this, but you need to know the terminologies. Which terminologies? Really, you know this one on the second exam, lecture exam. Acidophile means acid-like, and then neutrophil, neutral, and then alkalophile, alkaline. Mostly when we are talking about the pH, it is from 0 to 14. 0 to 14 scale. 0 to 7 is acidic, 7 is neutral. From 7 to 14, in this one it says 12, 7 to 14 is going to be, between 7 and 14 is alkaline. We call alkalophilus or basophilus bacteria, we call them. Okay, the bacteria which grow on this area. So remember that terminology. It's important for you. Ultraviolet light. When we are saying ultraviolet light, which you need to remember is the ultraviolet light is going to change thiamine dimers, A and then T, C and then G, especially in DNA. A and T, C and then G. These thiamine dimers are going to disappear in DNA, and then it is going to mutate. The shape is going to be changed. What kind of power we need to use for that? From between 100 and then 400 nanometer wavelengths we need to use. Between 100 and 400, you see. And then that is going to change the thiamine dimer. And then that is genetically, it is going to change or alter the genetical makeup of a DNA. That is one. Secondly, the DNA is going to mutate, you see. And then it is going to die even. So for this reason, when we are using ultraviolet between 100 and then 400 nanometer, we are killing bacteria when we are exposing it for ultraviolet light. That you need to understand it. Ultraviolet light is very dangerous one. You see now. So look now, it is going to have a different shape of ultraviolet lights. We are not going to worry about that one. And then how we are going to do ultraviolet, expose it, and then the letter is coming because they can pass. For example, if you are going to have a coffee can or certain things, let's say take a tube. If the bacteria is in a tube, you expose it to ultraviolet, you don't want it. You need to open it. If this is a plate, this is a plate, you want to expose for ultraviolet, you need to take the lid off and then expose it to the light. With a lid, you never kill the bacteria. Remember now, the ultraviolet, it doesn't pass the lid. That's why that 100 to 400 nanometer wavelength doesn't pass the lid. So for this reason, bacteria, it will not. For example, if you make a letter E and then it passes, that's why it make a shape of letter E. Look now. So remember now, enclose the product, even if it is candy one, if it is a tube, if it is a bottle. In a bottle, there are microorganisms. By ultraviolet, you cannot kill it. By boiling, yes, you can kill. You see. So for this reason, remember, ultraviolet, you need to expose the light, reach the microorganism to kill it. That's very important to understand. Okay, environmental, now enumeration of bacteria. How are you going to count bacteria? Yes, if it is solid media, you count the colony. That means colony forming unit. Okay, what is another one? I'll mention for you now. There is another way. Here now, very interesting. Here you are going to have dilution. From dilution, you pass it on the plate. Here now, I made it this one. You see, dilution, you pass it to the plate. Okay, and then you are going to find on the plate colonies. That means here, when you pass, you are going to pass colonies. In this one, you don't count colonies. To find the colonies, how many in this one or in this one, you need to pass it here to the plate, and then you count the colonies, colony forming units. So colony forming units are only showing the ones who are alive bacteria, not dead bacteria, alive bacteria. But we are having a friend now in laboratory, we call it a spectrophotometer. This spectrophotometer can read dead and then alive. The number of bacterial antigen or the number of bacterial cells are more counted by spectrophotometer than colony forming unit. Why? Because this is going to read dead and alive bacteria. That's beautiful. Dead and alive bacteria. So that, remember it, that's very important. Okay, this is disinfectant and then antiseptic. Disinfectant, we are going to use anything disinfecting chemicals on non-living things, not on the body. We call on fomites, we call it. On the table, we can use it. On the cars, we can use it. For non-living things, on the glass, we can use it, disinfectant. But when we are using antiseptic, it must be living things. It can be your skin or your tissue. And the hydrogen peroxide also categorized on this one also. Listerine, for example, you rinse your mouth and then you are rinsing microorganism from surface of your tissue. So it is antiseptic. Listerine is antiseptic. It is not disinfectant. Cepicol is disinfectant or antiseptic. It is antiseptic, but I didn't give you, so don't worry on that. So remember, antiseptics means to the cell for body or applied to the body. For hand sanitizers, applied to the body. And then 70% alcohol mostly in hand sanitizer is applied to the body. But bleach, you cannot use it. Bleach can be non-living things. Non-living things. So formalin, non-living things. You see, those are things which we need to remember. Okay, now, so that is going to show inhibition test. You see, inhibition test. So inhibition, we call it. So I will explain you on antibiotic area about inhibition test also. It is very similar on this one. Look now here. Susceptibility testing, we call it, with antimicrobial sensitivity. when we discuss. What does it mean? You know it. For example, you are streaking on the plate, and then you are going to have, for example, a disc, and then that disc which is impregnated or added already antibiotic on them already. So you are going to, those are added certain milligram of antibiotic also on the disc. You take that disc and then put it another disc, you put it. Maybe this is penicillin, this is tetracycline, this is vancomycin, you see. So you can pass it like this. The one which is showing higher inhibition is more sensitive. That means that microorganism is more susceptible to this microorganism, to this bacteria. You see, this bacteria is more susceptible to these microorganisms. I mean, so this is inhibition, we call it. We are going to mention the diameter, and then we know inhibition. How many centimeters? How many? How, if you can millimeter, how many millimeters you can do? So that we call it susceptibility test. We are going to test inhibition test. We call it as a general. That is susceptibility test or inhibition test, we call it. It inhibits the growth of bacteria. So that is inhibition test already. And then that is all inhibition test. This is an instrument which, this is some kind of apparatus having 8 antibiotics, and then those antibiotics are going to be used on the surface of the plate, and then we are going to see susceptibility or inhibition test we do. So that is just have an idea. Now, food microbiology. In this one, really, I'm not going to ask you any question on this one. So if there is a question on this one, I will remove it, even if I have done it already. And then when we are coming bacteriological examination of water, now this is, we are going to find Escherichia coli and then fusiform bacteria. Those are mostly the water contaminant. These mostly those fusiform bacteria, they are leftover, or these are microorganisms in our stool, you see, animal or dung or human. So for this reason, we are going to identify fusiform bacteria. That we call it determination of bacteria on water. So there is no question. And then effective hand washing, I'm not going to ask you also. Mostly it is PPE part. And then when we do surgeries, mostly we wash 7 times, and then we clean out bacteria. So it is very interesting. What you need to know in this one is our hands are very contaminated. Look now here, very interesting thing is we have done it in laboratory. We done experiment on this. And then how many times we wash? Up to 4 times we wash round 1. Look now how many. And then round it, second round. And then 4th round when you wash, there are bacteria. So when you go bathroom, and then after practicing being there and visiting there, you want to wash your hands, and washing hands with 1 time with soap, even it is not enough. So look now how we are in dangerous condition. We are really, it's very interesting now. So those are things which you need to understand when we are going to understand about PPE. Washing is not enough. Okay, now. So final one, I need to take attendance here. This is going to be, so you don't, if you say it hello or not, it doesn't matter now. So I took this one. And when we come to this one, it's a very interesting thing, which you need to understand. Why is it coming? Save, I said already. And then I said, yeah. So here, what you need to understand is, look now. What have you done last time? And then I'll give you some information. We are not going to use Pactorio system. You are lucky up to this semester. They are forcing us that we may use it during taking the exam, but it is our desire. Most of us, we didn't want to do it now. Most of us, we don't. So you don't need to worry on that. but you need to follow instruction and then read it. Especially those three things, read it. If you are not understanding, email me, email me, and then I will respond it to you. If you need explanation, I will explain it to you also. So email me in Canvas. I will always am around the Canvas really. Maybe I will be only 40 minutes or 50 minutes. I'll be apart. Otherwise, always I'm on the website. Yeah, really. So I will answer it. So for this reason, try it. If you have certain questions, finally, you may email me on Monday also. When you read something you don't understand it, email me and then I may answer it to you. No problem with that. Be prepared on that. This recording I send you already. So I will send you again today. You see, Marisol, I send it. You have it but I will send it today also. Okay, now, after I finish it, I will post it for you. Here, what you need to understand is going to be Ebola. On Ebola, there is some information I gave you. The information here, I took it very strictly because some students, they don't follow instruction really. Yeah, a few students, they don't. Why? I have seen it. When you write, also show me number 1, number 2, number 3. And then if you are going to grab it from Google area also, don't leave it as they are underlined because it is fraud you are doing. So that fraud, it will ask me also because I'm giving you points with that, you see. So you need to change it somehow. You see, some students, they don't change it, you see. You need to make it 2 to 3 sentences, join together and make it 2 sentences or something, you see. So try to make it, follow the instruction really. There is one time I gave 4 questions and then I said answer 2 of them. There are some students answer 4 of them. That is not right, you see. Follow instruction, you see. That's why I said comma kills a person. It is not a grammar kills a person. I said instruction kills a person. That a person, how he uses. So for this reason, please follow it. Instruction. In the future, to blame someone, follow the instruction. It is saving you, really. It's not with me only, with other teachers also. When you are working in work area also, just have an evidence for yourself. Really, follow it. For example, Ebola is a viral disease originated from continent named Africa. We said, okay, Africa. You can say Africa, but I told you that I modified. You can write it this sentence and then fill in the blank. It's okay. Or you remove these words and then leave me only one word. It's okay. I said also. I accepted. I didn't take points for that. This one, if it is true false question, I didn't give you. I think there is no true false question. It's okay now. And then on the third one, looking at here, really, here questions to be answered according to my explanation. I said I explain it to you. If you are present on my lecture, you need to answer it accordingly. Here what I said is, now look now, I said dash and dash species carry viruses. Okay, you say rodents and then insects. Okay, that's good. I said if you give any answer more than 2, if I ask you 2, you need to answer 2. If I ask you 3, you need to answer 3. If you are going to answer more than that, I will take points, I said. Look now, more than 2, I will take points. Okay, now, here I came to give you a question now. Here, for example, these are student answered. You know, the one who is answered is from this class, really. Look now, nobody missed other questions. There is only one student in this class missed this one. Only one. I don't remember the student name. This student knows the answer, but he or she, while she is writing or he is writing, instead of 1976, 1967, she wrote or he wrote 1976. That student know the answer. I'm 100% sure. But by writing, that student make a mistake. Only one student in the class. Okay, now. The other one is, the other ones all are correct. What you answered, all are good. In this one, good explanation. Even though some student, you have answered one word, it's okay. One sentence, it's okay. Now here, when you are going to come, this the only student, I don't have in this one even, missing the student, I think. Here, there are students who wrote from 14 or 10 to 14, you say. 10 to 14, it is not. Only 4 days, you see. So here, there is 1 point. All of them are having one point. But in this one, if there is insect and then rats, if you add 1, I'll take points. Instead of 2 points, you are going to get 1 if you write it 3. Even if you write 1, because it is not more than 1, I will not take points from you. Like now, if you are increasing and then adding, according to the video which you got, there are 3, but you want to write 3, my instruction says, if it is more than the prepared the blank, you don't need to give it. Follow instruction, really. Follow. Otherwise, I don't. So I'm going to make it this kind, another one also. Be sure when you are going to answer, please do it. Why you need to lose points on that? Easy ways you are going to get a point. For example, I gave activity today. I'm giving witness for you. In the morning, there are about 41 students. Only about 30 students answered the activity. Some of them, they didn't. You know, one student said, I have good points up to this time. If I don't want, I may leave this activity, she said. Yes, I said, yes, it is your choice. You see, your choice. If you are busy, you want to do something, if you don't want to answer it, it is your choice. I don't force, you see. That is how the student didn't do it. So only about 41, 11 students, they didn't do that activity because they say they have a good grade. Well, if you want, you can do that thing, the same thing also. Look now, please, it is activity. You go to websites, it is full of information. I'm telling you, I'm giving you more than 2 hours, but you can finish it within 20 minutes. I'm telling you. Why you need to lose points? Why? Why don't you do it? Please. Here, a few of you here in this class, really, up to this time, I see your grades are very high. And on this exam, do you know, there are students, when I give about 25 minutes on the 25 questions, there are students who finish within 10 minutes. Is it this much easy exam? I don't know, really. 10 minutes. There is no student who finished within 25 minutes. I think many of them finished it. Only one student come, I think, from the election or for voting done, and then lately she took the exam, and then that took the points, you see. She didn't finish the exam, you see. So I cannot do anything. I can't. So that is how you are going to do it. Every time when you are having the exam, please try it. I'm going to inform you on Monday night. I will inform you early in the morning also on Tuesday. On Tuesday also, I will inform you. Read it, please, read it. If there is something I can change, I will not change it. Okay, but the exam time is the same as before, unless we discuss together. So we are going to take at the same time, you see. So be prepared. If you are having any questions, what you are thinking, what it seems, but don't ask me individually. When you ask, this question is coming on the test, I will not answer it. No, I don't. No, this is unfair. The question must be explained for everybody, you see. So please try to make it. You have done good, really. I'm proud of you. And then some students who have done less, try to work on this one. This is not an easy exam, I'm telling you. It is not going to be like third exam. No, it's not. Little bit it needs reading. Please read them also. That's very important. And that is all I am going to say, really. And I'm very happy when I'm introducing this all. So we are lucky. If there is anything you are looking for, please, there is one student also asked me recommendation now. I said from the beginning, unless you finish the semester, I'm not going to write recommendation. Please don't. I have recommendation already ready. It's no problem for me. For A, B, C student, I have it, recommendation. So don't worry. If you are you finished, and then mostly I like when you are applying, Walano, please, I'm applying to this place. Can you fill me recommendation letter? That I like it. It takes about 5 minutes for filling up. First of all, before I do it, I'm going to write recommendation letter first, which I'm going to post on PDF. And then after that, I need to fill the application. You see, application. If you are not doing very well, I'm not going to write recommendation. Yeah. So try to work out very good. And then you are going to be happy. I'm going to be happy also while I'm recommending. I may have a cup of coffee. I'm enjoying to return your recommendation letter. And then when I check your names, accepted, I'll be very happy, you see. I know it. For example, Northridge University, I wrote about 40 recommendation letters. I'm telling you. From there, about 22 students are accepted. It's good. I'm very happy, you see. So for this reason, my recommendation is good, really. I'm going to do that. But you need to work good. If you are A student, recommendation is for A student. If you are doing for B student. You are doing C, I don't wish to write recommendation for C student, but I will do it also. That is what you need to do. Thank you very much. And then I am going to wait. If you are having certain things, email me. I am on the line here. I may, please don't talk on words. Just write it on chat. I will come and then answer it for you. I need to drink some water and then I'll come back. If you are having questions, I will answer it. Otherwise, go and then be on activity and then send me at the same time some recommendation. I will come and then answer it for you. Thank you again. And then see you. Be brave and have a good weekend.